variable. When we do regression analysis, if you remember, one of the one of the assumptions that we have the assumption of independence. We also have the assumption of the variable are fixed. They're not, they don't vary. They are fixed and they are measured without error. That's one of the assumptions that we have in regression analysis. Within structural equation modeling, we can relax this assumption and trying to incorporate what is measurement error within our estimate. Then we have the ability of model mediating variable. I will talk a lot about, I will show you what that means and how we can estimate that. We have, we can do group comparison, so group analysis. Then I can have a model, but I can test if this model is the same, let's say for men and for women, if the same kind of relationship that I think are the same between both of them, or should I specify different model for each group? This kind of analysis you can actually do. It doesn't have to be men and women, it can be any of the two groups. We can, this is a powerful model. You can have longitudinal data, you can have repeated measure within the model. We can have multi-level model. That means we can have people nested within classroom and classroom nested between school. We can have this kind of model. We don't have to have normal data. We can have non-normal data. We can have incomplete data, but we still cannot determine cause and effect. We need experimental data to see that. It's the same thing with explanatory factor analysis. We are working with the matrix of correlation or matrix of covariance. Since we are working, the relationship can go both ways. Then what we're trying to establish are relationship between the variable. We're not saying this variable cause this other variable. There are relationship, correlation between the variables. That means there is some downside of the model in that way, because the relationship can always go both ways. How we decided which way is best. Now we will start going with some of the concept that is used in this model. One is observed variable. We can decide they are measured in our study. They are observed variable. That means they are in our data set. That will be age, gender, all the covariates that are already in our data set, the measures that are in the study. The latent variable, it's what I call the latent construct. It's why in factor analysis we call factors or dimension. Those are variables that are not in our model, but they are bring about by the observed variable. They are latent construct of the relationship between the observed variable. The other two concepts that we have to consider is exogenous variable and endogenous variable. Exogenous variable mean they are external in our model. Those are variables that are external. We're not trying to explain them. They are given in our model. Between them, they can only have correlation between them. But we also have the endogenous variable. Those are, I will call those are the dependent variable in our model. the the things that we can have combination of them. We can have a latent variable that is endogenous. That means we trying, there is an arrow that go to it, we're trying to see the relationship. The latent variable become a dependent variable. There's something that is explaining it within the model. The latent variable can be exogenous, that doesn't mean it doesn't. He explained other variables, but nothing, there's a relationship with other variables, but there is no relationship with the latent variable. That's the way. That will be more clear when I go into how we present this, usually as a graphic. Then we have the square that is always the observed variable. The second, we call it latent variable, is the way we represent it in the model. We have a direct effect that's saying these variables has relationship with the other one. Like it's a covariate of the dependent variable. Then we can have, since we're working with the matrix of correlation, we can have arrow that go both ways, direct effect that go both ways. And we have correlation between variables or covariance between variables. Then if we go back to this, first, yeah, if we go back to this, we can actually know which are the latent variables. We have two latent variables. We have, those are on square, they are observed variable. But these become an observed endogenous variable because it has a direct arrow going to it. There is two covariates that explaining the relationship between these. And this is a latent variable, but it has a direct arrow going to it. This latent variable become also an endogenous variable. This is a part of a model where we are saying, I should explain what all this means. This is light satisfaction. I'm saying this model is saying light satisfaction depends on the quality, health-related quality of life and individual characteristics. For health-related quality of life, we are using this variable to measure it. One is my general health status, my physical health, and my mental health. Then these variables are exogenous variables that are used to explain to capture the latent variable that is health-related quality of life. This is what I will call a confirmatory factor analysis because I'm assuming these are exogenous variables, but they are measured with error. That means the error associated with them. And for individual characteristics, I'm considering education and income. That's probably a measure of socioeconomic status. This is part of one of the model and we will find the theory explaining life satisfaction, quality of life. Questions so far? They are new concepts. You can ask questions if you don't understand. For me, they're easy. I've done this every day. Then for me, I just go and write to them. If you have questions, ask them.
less satisfactory, you said
That's a dependent variable, that's
yeah.
an endogenous variable
Okay.
within the model.
That's a dependent variable.
Yeah, that's our main dependent variable. We're
Well,
saying it's related to these two variables.
okay.
This
What about education and income?
education and income, those are two variables we are trying to use to measure the latent construct that we call individual characteristics.
So are they?
Is
Are
that
they
and
independent
okay?
or
But
no?
when I talk about confirmatory factor analysis, I will go into detail why this error that go to the dependent variable are different with that one.
Okay.
We will solve that. We will see that in detail okay. Structural equation modeling is a combination of two techniques that exist and two multivariate exist that have been using widely. One is path analysis. Path analysis, regression, we can understand regression analysis as a path analysis because it shows relationship between observed variables. Only in regression analysis there is one dependent variable